Martin, what is quantum physics?
Quantum physics deals with the very small. In the ordinary world, we expect that the measurements we make and the way things happen is continuous. And by that I mean that a car can travel at 50 miles an hour, it can travel at 50.1 miles an hour, it can travel at 50.11 miles per hour. We don't expect there to be limits on the speed that a motor car can travel. But in the world of the very small, energy and other things are quantized. In other words, we're dealing with quanta. Now, the best example of this is electrons spinning around the center of an atom. And electrons just can't take any old orbit. They have to take, orbit number 1 or number 2 or number 3 that are in well-defined places. And so their energy is quantized. There's certain quanta of energy it can have. So the equivalent in the motor car would be you can only travel at 50 miles an hour, 70 miles an hour, or 100 miles an hour. You can't travel at 60, or you can't travel at 88 miles an hour. So the speeds are quantized, and for very small particles like electrons, then the energy and the things they can do is quantized, hence the name quantum physics. Now, there are problems trying to deal with the very small, and in the conventional way anyway. So instead of using what you might call continuous mathematics or deterministic mathematics, if you travel at 60 miles an hour for an hour, you'll travel 60 miles. It's deterministic. But in the world of the very small, things are not really so deterministic. You have to use probabilities, probability theory. So what you'll find is that in quantum physics, the main mathematical tool is probability theory, not classical mathematics in the sense of 1 plus 1 equals 2. In the world of quantum physics, 1 plus 1 might equal 3. It's so unintuitive. And of course, you will have heard of the Heisenberg uncertainty principle if you've watched Breaking Bad. And what Heisenberg said roughly is that if you want to know the position of a particle, you cannot know its velocity at all. If you want to know its velocity, you cannot know its position. And there's a formula that relates position and velocity together. And the more you want to home in on one, the less you can home in on the other. There's uncertainty again. So it's a whole new world, really. I mean, quantum mechanics has been around, or quantum physics has been around for 100 years, but people don't really understand it. They know how the math works. The most famous equation in quantum physics is the Schrödinger equation, which actually isn't all that complicated. Depending on what you're trying to apply it to, isn't all that difficult to solve. But there are more and more strange effects starting to appear from quantum physics, one of which is called non-locality. It basically means that two particles that have in some way interacted can eventually find themselves on the opposite end of the universe, but they can communicate instantaneously. There's no distance, hence it's called non-locality. And for a long time, people thought that, well, that might be breaking the rule that the fastest thing that can travel is a ray of light. But there are problems trying to use this mechanism of non-locality, entanglement, which I won't go into. But basically, you can't use it to pass messages, or so it seems at the moment. Anyway, if you think that quantum physics is a bit abstract and not applicable, you'd be completely wrong. You would not be listening to this if it wasn't for quantum physics, because quantum physics is applied rigorously to the use or the development of semiconductor chips. And so without that, we wouldn't have the world of electronics that we know today. And it's used every day in designing chips and semiconductors. So it's a very, very practical thing, although oddly enough, nobody really understands what it means.